This question is from GATE 2016, Mechanical Engineering Paper Set 1, question number 35. A slider crank mechanism with crank radius 200 mm and connecting rod length 800 mm is shown. The crank is rotating at 600 rpm in the counterclockwise direction in the configuration shown. The crank makes an angle of 90 degree with the sliding direction of the slider and a force of 5 kN is acting on the slider. Neglecting the inertia forces, the turning moment on the crank in kilonewton meter is dash. Let's find out. Now we need to find out the turning moment on crank. This is the crank and we have to find out the turning moment on this member. So we'll have to transfer this force 5 kN onto the crank. So we can transfer this as 5 kN direct force and there will be a moment acting. This is nothing but the turning moment at the crank. What will be this moment that we have to apply here in order to transfer 5 kN to this point, to the end point of the crank? It will be simply turning moment T equal to 5 kN, which is 5 into 10 to the power 3 Newton, into this distance. This distance is given to be 200 mm. So it is nothing but 200 into 10 to the power minus 3 meter. This is in Newton. So we have converted this in meter so that we get the answer in Newton meter, which is equal to 5 into 10 to the power 3 into 10 to the power minus 3. So it's simply 5 into 200, which is 1000 Newton meter. We have to write the answer in kilonewton meter. So it is T equal to 1000 by 1000, which is 1 kilonewton meter. It's as simple as that. The main concept here is to transfer this force of 5 kilonewton to the end point of the crank. That will simply give us the turning moment acting on the crank. I'll go back and fill in the answer. Neglecting the inertia forces, turning moment on the crank in kilonewton meter is 1. To learn more about balancing of single slider machines, you can refer to the NPTEL video, Module 4, Lecture 1, Balancing of Single Slider Machines. This video is from the course Lecture Series on Dynamics of Machines. The course is by Professor Amitabh Ghosh. He is from Department of Mechanical Engineering of IIT Kanpur. I hope the solution will help you clear your doubt. Thank you.